In this lesson, we're going to look at finding the least common multiple, the LCM, of two or more terms. Now, this topic, the idea of finding the least common multiple, is going to be important when we start talking about adding and subtracting fractions. Because remember, when you add and subtract fractions, we're going to have to find the least common denominator. And there's a relationship between the least common multiple and the least common denominator. So that's why we need to we need to understand how do we find the least common multiple of two or more terms. Now we're going to start out with a very simple example. So let's look at this example. So we're going to find the least common multiple. Find the least common multiple of 6 and 12. So number 1, 6 and 12. Okay, find the least common multiple of 6 and 12. Okay, so notice in the phrase least common multiple is the word common. Okay, common multiple. Common multiple. So if I look at 6 and 12, one way to find the least common multiple is to actually list the common multiples. And then you pick the one that's the least. Okay? So that's one way. The other way is to use prime factorization, which you did when we talked about greatest common factor. So we're gonna kind of review greatest common factor in a little while, so that because some students get this and greatest common factor confused. All right, so the least common multiple of 6 and 12. So let's go ahead and write the common multiples of each of those. So let's write the multiples of each of those. So multiples of 6 are, all right, now, again, if you need to use your calculator to help you. So here's how we find the multiples of 6. First of all, do y'all agree that 6 is a multiple of itself? Because 6 times 1 is 6, and 6 goes into 6 evenly. The next multiple of 6 is 12. Why is 12 a multiple of 6? Because 6 times 2 is what? 12. 6 goes into 12 evenly. Okay? The next multiple is what do you think? The next multiple, yep, 18. Because 6 times 3 is 18. And then here's a question. How many multiples of 6 are there? Well, they're an infinite number. And so if you can just use your calculator, and then you'll get the next one is 6 times 4, which is 24. 6 times 5, which is 30, 6 times 6, which is 36, 6 times 7, which is 42, 6 times 8, which is 48, and then so on, right? 6 times 9, which is 54, okay? And I'm running out of room, so I'm just going to put ... All right? And then let's look at the multiples of 12. Multiples of 12. So these are the multiples of 12. So the multiples of 12 are 12 times 1 is 12. 12 times 2 is 24. 12 times 3 is 36. 12 times 4 is 48, right? 12 times 5, use your calculator if you need to. 12 times 5 is 60, and so on. Y'all agree? All right, so how many multiples of 12 are there? There's an infinite number of them. Now, what I want to do now is talk about, well, what are the common multiples? So I'm going to circle the multiples that both of those have in common. So here's the question. Do they both have 6 in common? Nope, because I don't see a 6 here. They have a 12 in common, so I'm going to circle it. They have a 24 in common. I'm going to circle it. They have a 36 in common. I'm going to circle it. They have a 48 in common. I'm going to circle, and so on. Okay, so when you look at the least common multiples of 2 or more terms, there will be an infinite number of common factors. But when I'm finding the least. So the question is, of those I have circled, what is the least of those? The least of those is 12. And so that's how you can find the least common multiple. So you can find the least common multiple by finding the multiples of each, just like I did. Okay, and then picking the one that's the least. Now, I want you to think about this. Notice, you see how I wrote a bunch of those? You don't have to do all that. You could just do a couple or a few of these and do a couple of these, and then sometimes you get it right away. So you don't have to go any further. I went further to talk about the discussion, to talk about what do we mean by multiples, what are the common ones, and then the least would be the smallest one that they have in common. So that's the least. So the least common multiple is 12. So the least common multiple of 6 and 12 is 12. Okay? So through experience, when you do more and more of these and you start thinking about this with your reasoning skills, you can find the least common multiple of 6 and 12 without even doing any work. Many of you know that the smallest number, remember the least common multiple would be the smallest number that those two divide into evenly. So 6 goes into 12 and 12 goes into 12. So that's the least common multiple. So some problems, some terms will be easy to deal with, some terms will not. So in those cases, you may need to write the multiples of each one and then find out which one's the least. Okay? But here's another way to do this. And the other way is to look at the prime factorization. Other way is to use prime factorization. So you may remember that in this course, because we did use the idea of prime factorization when finding the greatest common factor, the GCF. So what we need to do is find the prime factorization of 6 and 12 first. Okay, just like we did the multiples of 6 and 12, we're going to do the prime factorization of 6 and 12. Now remember what prime factorization means. Prime factorization it means that we're going to write each of the numbers 6 and 12 as a product of prime numbers. Product of prime numbers. That's what that means. So right away, the prime factorization for 6, most of you already know that, is 2 times 3, because 2 is a prime number and 3 is a prime number. Okay? The prime factorization for 12, some of you are going to say, I'm going to write this here, some of you are going to say, well, the prime factorization of 12 is 6 times 2. Nope, it's not. Why not? Why is a prime factorization of 12 not 6 times 2? Well, because 6 is not a prime number. That's why. 6 is a composite number. 2 is prime, but 6 is not. But then even if you did this, you now know this. Oh, but 6 I can write as 3 times 2, right? And so that's times 2 for this one. So the prime factorization of 12 is, I'm going to put this in order. So it'll be 2 times 2 times 3, or you can say 2 squared times 3. Okay? All right? So that's the least, that's a prime factorization for 12. Now, remember the other way we did this was the factor tree. So remember the factor tree. So you think of two numbers whose product is 12, but don't use 1, because 12 times 1 is 12. So you're kind of wasting some space here. So like 4 times 3 or 6 times 2, does not matter. 3 is prime, so we circled it. 4 is not prime. 4 is composite, so we went further. So 4 is 2 times 2, and then we circled that. Remember that? And so therefore we get 2 times 2 times 3, which is what you see here. All right? All right, so let's talk about the least common multiple now using prime factorization. We know the answer is 12, correct? All right, so we know the answer is 12. So I want you to think about that in terms of what the least common multiple is. So remember, the least common multiple based on what we've done so far means this. So let's look at this right here, least common multiple. Now we're dealing with numbers, so I'm going to use the word number. So it's the smallest number that all terms or all numbers divide into evenly, right? So if I look at 6 and 12, the smallest number that 6 and 12 divide into evenly is 12. 6 divides into, I'm going to do it here, 6 divides into 12 evenly, and 12 divides into 12 evenly, and that's the smallest one that both of those divide into evenly. There's an infinite number of those. 24 is a common one, 36 is a common one, but 12 is the smallest, hence the word least. Okay? Hence the word least. So when we talk about the least common multiple using prime factorization, when we talk about the least common multiple using prime factorization, I need for you to remember this, and this is hard to understand at first. So the least common multiple using prime factorization must include every factor you see. Okay, must include every factor you see, and I'm going to leave that space off for a little while. So I'm going to go back and go write this. So the least common multiple, I see a factor of 2. I see 2 of them here, right? So I need a factor of 2. I see a factor of 3, don't I? All right, I see a factor of 3, so I'm going to use 1 here. So I need at least 1. Now be careful, that's not the answer, because 2 times 3 is 6, and we know the answer is 12. Okay? All right, so here's the other thing you got to remember. So it must include every factor you see and use the factor, use factors that occur the most often. Okay, now I know that doesn't make any sense, but listen to what I'm about to say. So I need a factor 2, right? Okay, so how many factors of 2 are in 6? 1. How many factors of 2 are in 2? I'm sorry, 12. 2. So I need 2 of them. So you use the one that occurs the most often. So 2 factors of 2 occurs here, and then there's only 1 factor of 2 here. So I'm going to need 2 factors of 2. So let's go to 3. So 3, I have 1 factor of 3 here, 1 factor of 3 here, so I only need 1. So notice I get 2 times 2 is 4, 4 times 3 is 12. Okay, so the least common multiple of 6 and 12 is 12. Okay, let's look at another one. Okay, this will be number 2. So number 2, let's suppose we had this, and we're going to use a prime factorization, and we're going to talk about this again. Okay, so let's talk about number 2. So number 2, let's suppose we want to find the least common multiple of, let's say, 9 and 12. 9 and 12. Okay? So let's go ahead and talk about prime factorization. Let's do it that way, because I really need for you to understand this. So the prime factorization of 9 equals, y'all agree it's 3 times 3, right? Or 3 squared. The prime factorization for 12, that's going to be 2 times 2 times 3. Y'all agree? Because 2 times 2 is 4, 4 times 3 is 12. Or 2 squared times 3. Okay, so listen carefully to what we were talking about here. All right, so the least common multiple must include every factor you see, and you're going to use the factor. You're going to use the exponent. The exponent will be the one that occurs the most often. All right, so here's what I mean. So if I look at 9 and 12, I see a factor of 2, right? Now you may say, well, there's no 2 here. It doesn't matter. It does not matter. I must use it. So the least common multiple, I must include a factor of 2. Okay? And then the question is, how many do I need? I don't have any here. I have 0 here. I have 2 here. So I must use 2. Okay? The next factor I see is a 3. So I must put a 3 down here. The question is, how many do I need? I have 1 factor of 3 here, 2 factors of 3 here, right? So I need 2 of them. You use the one with the largest exponent. 3 to the first, 3 to the second. And here's why you need the one with the largest exponent. Okay, so let's go to the 3. So remember the least common multiple. So this 3 must divide into this least common multiple, right? And it does, because 3 goes into 9. Y'all agree? Here I have a 9. 3 times 3 is 9. So 9 must divide into this, and it does, because that's 9. So if you just had 1, if you just had just the 3 and not 9, 9 doesn't go into 3. 9 does not go into 3. All right, so that's why we have to use the one with the largest exponent. That's the only way. The largest exponent is the only way that you'll get these factors divide into the least common multiple evenly. Okay? All right. And then notice I need factors of 2 because I need this number here to divide into this. And so if that number divides into your least common multiple, then these factors have to divide into that as well. So if you did not include that 2, if you just said, well, the answer is going to be 9, the problem is that 12 doesn't go into 9 evenly, right? Because of these 2's right here. So you need to put some 2's in here, and you need to put the maximum number possible that you have. So I have 2 factors of 2, so I need 2 of them. Okay, don't put any more because you're finding the least. You're finding the least. So therefore the answer is going to be 2 to the second power, which is 4, and then 3 squared, which is 9, so the answer is 36. So that's the least common multiple, 36. All right, and then let's look at this in terms of common multiple, write out the common multiples. So the common multiples of 9 are 9 times 1 is 9, 9 times 2 is 18, 9 times 3 is 27, 9 times 4 is 36, 9 times 5 is 45, and so on, right? And then for 12, the common multiples of 12 are 12 times 1 is 12, 12 times 2 is 24, 12 times 3 is 36, and I'm stopping because I found the least. And what's the least? 36. So it is important that you're able to do both. Use prime factorization and then use this. Now notice though, I'll be honest with you, number 2, if you didn't know what the least common multiple was right away, then listening to them is probably easier than this. Okay, because you get it right away, right? But it's not always going to be that simple, so you need to know this as well. So you gotta be able to understand both ways. The more things you have in your toolbox, the easier it is to synthesize all the information that's needed to get to where you need to go academically. Okay, so let's look at number 3. Number 3, let's say we had 35 and 49. 35 and 49. Okay, so number 3, 35 and 49. So if I look at 35 and 49, probably writing the common multiples of those it may not be easy. Maybe it might. I don't know. But what I want to do though is look at this in terms of prime factorization, because I need for you to understand how to find the least common multiple. So let's look at the prime factorization. Prime factorization. Now actually the prime factorization is pretty quick, because look, so for 35, y'all agreed that 35, the product of prime numbers would be 5 times 7, and right away you're done with 35, right? 5's a prime number, 7's a prime number. And for 49, y'all agree that's 7 times 7, okay? And so therefore the least common multiple, okay, listen to what I was trying to say here. The least common multiple, you have to include every factor you see. I see a factor of 5 and I see a factor of 7. The question is, how many do I need though? How many factors of 5 are in this one? There's just one. How many factors of 5 are in this one? 0. So you need how many? 1. Okay? How many factors of 7 are in here? 1. How many factors of 7 are in here? 2. Now remember, the least common multiple, the sevens, the factors of 7s must go into this one evenly. Okay? So here's the question. 7 times 7 is 49. Does 49 go into 7 evenly? Nope. But 49 goes into 49 evenly, right? And then 7 goes into 49 evenly as well. So when finding the least common multiple, you must use the one that has the largest exponent. So the largest of 1 and 2 is 2. And so therefore the answer is 5 times 49, and then 5 times 49 on your calculator is 245. Okay? And so it's quicker just go ahead and do it that way. So it's quicker to go ahead and do it that way rather than listen to common multiples, at least for this one. All right? Now, what I want to do before I go into the next one is kind of review the greatest common factor before we continue on with the greatest common multiple. So let's go back to number 1, and I need to kind of talk about that for a moment. So remember in number 1 we talked about the least common multiple, and so the least common multiple of 6 and 12 is 12. So that's the smallest number that 6 goes into, and 12 goes into evenly, right? Is 12. So hence the idea of least common multiple. So do you remember how to find the greatest common factor? So let's kind of review the greatest common factor, because some students get confused between the two when they deal with prime factorization. So when they use prime factorization, they get confused. So when we look at the GCF of, let's say, number 1, 6, and, what did I say, 12? Okay, 6 and 12. So when I look at the prime factorization, so remember the prime factorization of 6 is 3 times 2, and the prime factorization of 12 is 2 times 2 times 3. Okay? And so when finding the greatest common factor, so remember, in finding the least common multiple, we must include every factor we see, regardless of if it's in both. We got to include every factor we see. Okay? The greatest common factor, remember that definition, the greatest common factor is the largest, in this case we're dealing with numbers, so the largest number that divides into each evenly. Okay, so what that means is this: whatever I use for my greatest common factor, that factor has to be in both of those. So you see, I have a 2 in here and I have a 2 in here, so I have to include because it's in both. The question is, how many do you need? So you got to use a 1 that's the smallest of those. So in finding the least common multiple, you included the larger exponent. When finding the greatest common factor, you include the least. So this is 2 to the first, this is 2 to the second, and so we need just 2 to the first. Okay? Then the other factor they have in common is 3. I have 1 here, so I need just 1. So that's where we get 6 as the greatest common factor. Okay? So we're going to come back and do another one in a little while. So I'm going to go off and continue talking about least common multiple. So we did number 3. Let's look at number 4. So this will be number 4. So number 4, we have this. Number 4. Okay, so number 4, let's suppose we have 9 and 21. Okay, so the least common multiple. We're finding the least common multiple. All right, so let's go ahead and just talk about prime factorization, because I need for you to get a handle on that, prime factorization. So the prime factorization of 9, that's easy. That's 3 times 3, okay, or 3 squared. The prime factorization 21, that's easy as well, because that's 3 times 7, okay? That's 3 times 7. So remember, the least common multiple must include every factor you see, because remember, the least common multiple is going to be bigger than which of these numbers? The least common multiple is going to be bigger than or equal to 21. Okay? The least common multiple will be bigger, greater than, or equal to 21. So when I find my least common multiple, 9 has to go into that also. Okay? So I've got to use every factor I see. So I see a factor of 3. It's in both. Does it have to be in both? Nope. Does not have to be in both. But it is in both here. So I have two factors of 3 here, so I need a factor of 3. So I have two factors of 3 here, 1 here. How many do you need? You got to say both. You got to say 2, because if you say just 3, okay, see, 3 times 3 is 9. Does 9 go into 3 evenly? No. So you need the largest exponent. So in finding the least common multiple, you got to use the largest. So I want you to think about this. So the least common multiple of 9 and 21 has to be greater than, listen to me, greater than or equal to. So you remember I said the word greater, right? So when I said the word greater, think largest. I got to use the largest exponent. Now, I must include 7 as well. Even though 7's not in this one, I have to use it, right? Okay, because that's the only way I can get a number greater than 21 that both of these go into evenly is to include a 7. Question is, how many 7's do you have here? 1. How many do you have here? Factors of 7 you have here? 0. So I need just 1. And so the answer now is going to be 9 times 7, which is 63. Okay, so that's how you find your least common multiple. So now what I want to do is I want to go back to the GCF now. So let's do this one. It's number 2. Let's find the GCF of 9 and 21. So the GCF of 9 and 21. So the prime factorization of 9 is 3 times 3. The prime factorization of 21 is 3 times 7, right? And remember, that's also 3 squared. Okay, so when talking about the greatest common factor, the greatest common factor has to be less than or equal to 9. Y'all remember that? So the greatest common factor, the greatest common factor, remember, is the number that divides into each term evenly. So the factor that goes into 9 and goes into 21 evenly is going to be 3. Okay, so let's see how we can get 3 from here. So the greatest common factor, remember, the greatest common factor has to be less than or equal to 9. And whatever number I use, it has to also be a factor of 21. All right, now when you notice I said less than or equal to, right? So less than or equal to, think least, think smallest. All right, so the greatest common factor, when finding the greatest common factor, remember, the greatest common factor will be a factor that goes into here and here, which means that it's got to be in common to those. So which factors do you see they have in common? They only have a 3 in common. Do you see they have a 7 in common? Yes or no? No. So I'm not going to use it in my greatest common factor. When finding the greatest common factor, I've got to use the factors they have in common. So they have a 3 in common. And the question is, how many do I need? So remember, the greatest common factor is less than or equal to 9. So use the one that has the smallest exponent. 3 to the first, 3 to the second. I just need 3, and there's your GCF. And we said that was the GCF. Okay, so it's important to go back and review, well, how do I find the GCF using prime factorization? And then how do I find the GCF using least common, how do I find the least common multiple using prime factorization? Okay? All right, let's look at number 5. So let's find the least common multiple for number 5. So number 5, let's suppose we have 3 numbers now, 20, 190, and 38. So sometimes, and you will have more than 2 terms at times. So sometimes you got an idea to actually use the prime factorization. So let's talk about 20. So let's go and do it that way, 20. So the prime factorization of 20, will be, remember, find the least common multiple. Least common multiple. So the prime factorization of 20, let's see, what's that? 10 times 4? I'm sorry, 10 times 2, right? 2 is prime, so I'm going to circle that. 10's not, so that's 2 times 5, and both of those are prime. So the prime factorization of 20 is 2 to the second power times 5. Okay, now let's look at 190. 190, the prime factorization is, let's say, 19 times 10. All right? And then 19's prime, 10 is not, so that's 2 times 5. And now I know that 190 is 2 times 5 times 19. And I'm just putting in numerical order. And for 38, I get, let's see, 38, 38 is even. So if you want to start with a 2, you can. You can say 2 times, and then just if you need to use your calculator, you just say 38 divided by 2, and you'll get 19. And hey, we already have it. 2 times 19. Those are prime numbers. All right. So once you do the prime factorization, the least common multiple is easy. So remember, the least common multiple has to be bigger than or equal to the larger one you see. So when we figured out the least common multiple is going to be bigger than or equal to 190. Okay? So remember, in that case now, I've got to use every factor I see. For the GCF, it was the ones that had in common. That's not true for the least common multiple. Least common multiple is any factor you see, any prime factor you see. So I see a 2. It just so happens that 2's in all of them. Did not have to be. So let's talk about how many I need, though. How many factors of 2 do you have here? I have 2 of them. How many factors of 2 you have here? I have 1, 2 to the first. How many factors of 2 I have here? I have 1. So how many do I need? Remember, it's got to be greater than or equal to 190. So you need the one that's the largest exponent. Greater than or equal to, think largest. So I need 2 of them. Times. All right. Now, I see a factor of 5. You may say, but there's no factor of 5 here. It doesn't matter. We're talking about a least common multiple. All right. So the least common multiple has to be bigger than or equal to 190. So that means that 20 has to go into that number as well. So that means that I need a factor of 5. So in order for 20 to go into the least common multiple, 5 has to go into it also. Okay? So in order for 38 to go into that least common multiple, since 5 goes into this, then 38 will have to go into that as well. Okay? So I need how many factors of 5? I have 1 here, so I just need 1. I have a 19, and there's no 19 here, but it doesn't matter. So I need a 19, a factor of 19. The question is, how many do I need? Well, I have 0 here, 1 here, 1 here. I just need 1. And all you do is just multiply this out. So 2 to the second power is 4. Okay, so you can get 4 times 5. Use your calculator. 4 times 5 times 19 equals 380. If you would have gone ahead and just listed the common factors, you would have had 20 a bunch of times, 20, 40, 60, 80, and so on. So it would have taken you a while. It would have taken you a while to actually list the multiples of each of those until you get the one that's the least. So that's why it's important. That's why it's important that you know both ways, using multiples and then finding the one that's the least, and then using prime factorization. Okay, you got to know both ways. All right, let's look at number 6. Oh, by the way, so what? Suppose I want to find the greatest common factor. Let's see if you can do that now. So I'm going to go here. I'm going to say the greatest common factor of 20, 190, and 38. So I want to find the greatest common factor, okay? So 20 we know is the prime factorization is 2 to the second power times 5. 190 we know is 2 times 5 times 19. So they'll all, remember, prime factorization, a product of prime numbers. All those are prime numbers. And then 38 is 2 times 19. So the greatest common factor, you must use any factor they have in common. So here's a question. Am I going to use a 5? No, because they don't have a 5 here. Am I going to use a 19? No, because there's no 19 here. So what's the only factor they have in common? Well, the only factor they have in common is 2. And the question is, how many do you need? Okay, so remember, the greatest common factor will be less than or equal to 20. Okay, so then that means that in terms of your exponents, you're going to use the one with the smallest exponent. So how many 2's do you have here? 2. How many factors of 2 you have here? 1. How many factors of 2 you have here? 1. So the greatest common factor is 2. Okay, so notice the greatest common factor of those three numbers is 2. The least common multiple of those three numbers is 380. Okay, all right, so that's number 5. Let's look at number 6. So number 6, we have this in number 6. So let's suppose we had 32 and 50. 32 and 50. Okay, 32 and 50. All right, so let's go ahead and do this by prime factorization. So 32 will be, so let's look at that. So 32, the factor tree. So I know that's 2 times what? 16? 2 is prime. I'm going to circle it. 16 is 2 times 8 or 4 times 4, whatever you want to use. 2 is prime, so I'm going to circle it. 8 is 2 times 4. 2 is prime, and 4 is 2 times 2. And so I get 2 to the 1, 2, 3, 4, 5 to the 5th power. Okay? And then 50 is 2 times 25. 2 is prime. 25 is 5 times 5. And so that's 2 times 5 squared. Okay? And so therefore the least common multiple, remember the least common multiple is going to be greater than or equal to 50. Because 32 has to go into that number. So it has to be, so 32 and 50 has to go into that number evenly. So it has to be greater than or equal to 50. So remember the least common multiple has to include every factor you see. Every factor you see. So I see a factor of 2 and I see a factor of 5. So I know I'm going to have some factors of 2 and some factors of 5. So at least one factor of 2 and one factor of 5, right? And so remember, the least common multiple must be greater than or equal to 5. So in terms of exponents, you use the one with the larger exponent. So how many factors of 2 do you have here? 1. How many factors of 2 do you have here? 5. How many do I need? 5. How many factors of 5 do you have here? 0. How many factors of 5 do you have here? 2. So how many do you need? 2. And so therefore, just use your calculator. 2 to the 5th. So look, 2 to the 5th. 2 to the 5th is 32. And then 5 squared is 25. And so therefore, 32 times 25 will give you 800. So that's the that's the smallest number. That's the smallest number that 32 and 50 go into evenly. That's the smallest number. So if you were to actually list all the common factors, you'd be here for a few minutes trying to find out which the least of those. So that's why it's important. That's why it's important you know how to find the least common multiple using the prime factors. Now let's go and actually find the greatest common factor of those, just to kind of make sure you understand that. So the greatest common factor of 32 and 50. So again, 32 we know is 2 to the 5th, and then 50 we know is 2 times 5 squared, right? Okay, so the GCF remember is what's the largest factor that goes into both of those. Okay, so greatest. So the greatest factor that goes into 32 and to 50 evenly. So the greatest common factor will have to be less than or equal to 32. Okay? Greatest common factor has to be less than or equal to 32. So whatever factors I put in here, it has to be common to both of those numbers. So when finding the greatest common factor, you look at all your factors and you use the one that they have in common. So I'm not going to use a 5 here because there's no 5 as a factor here. But there's a 2 in both of those. There's at least one. There's 1 here and then 5 here. So I need at least one factor of 2. And the question is, how many do I need? Well, remember, you can't use 2 to the 5th, right? You can't use you can't say, well, I'm going to use all 5. You can't, because that's 32, and 32 doesn't go into 50 evenly. So you know that can't be right. So always think about what we were saying. The greatest common factor is going to be less than or equal to 32. And so when I use the word less than, think of the smallest exponent. So here I have 5, here I have 1, so I need just 1. All right, so again, understand why I couldn't use 5. Because 2 to the 5th is 32, and you're saying that's the greatest common factor. Yes, you're right. 32 goes into 32, but does 32 go into 50 evenly? No. All right, so you got to be careful with which exponent you use. So that's why you got to use the least exponent. And so the answer is 2. So 2 goes into 32, and then 2 goes into 50 evenly, and that's the greatest common factor. All right, and so if you look, I want to show you this. So watch. Let's look at the factors of 32. The factors of 32 are 1. 1 times 32, so 32 is a factor as well, right? Okay. The another factor of 32 is 2, and 2 times what is 32? 16. So 16 is also a factor of 32. Okay. Another one will be 4. 4 is a factor of 32. 4 times 8 is 32, so 8 is a factor of 32. And so those are all the factors. Those are all the factors. So let's look at 50. So 1 and 50 are factors of 50, because 1 times 50 is 50. 2 times 25 is a factor, are factors of 50, because 2 times 25 is 50. 5 is a factor of 50, right? Because 5 times 10 is 50, so 10 is also a factor of 50. And so I think that's about it. So those are all the factors of 50. And let's look and see what they have in common. So the common ones would be 1, okay, 1, 2, and that's it. You'll see that? That's it. And now you're looking for the greatest common factor. So what's the greatest common factor? The greatest common factor is 2. All right? So it's important to understand how to find the greatest common factor and the least common multiple using prime factorization, and using, in this case, since we're dealing with common factors, or in the previous, if I can find it real quick, in one of the previous problems, the multiples. Okay? All right. Now, in this lesson, all we did, if you go back, was we looked at finding the least common multiple, of numbers. We found the least common multiple of numbers. In the next lesson, we're going to include variables. We're going to include variables in the next lesson. So this lesson, next lesson go together. When we talk about the ones with variables, those are easy to remember. As long as you can understand how to find the least common multiple using prime factorization, you got the variable ones. All right, so the next lesson is a continuation of this, but instead of just numbers, you're going to have variables. Okay? All right, so that's going to be the end of this lesson. But remember, this lesson and the next lesson go together.